Hi everyone! Electric skateboards. They started to be popular in 2015 and now there is just more and more and more of them. And I always thought they were quite cool, but let's just say where I live, the quality of the roads isn't the best. So for me there was no point in buying one because I would just simply fall into the hole in the road at high speed and kill myself. But then one day I realized that there is different type of skateboards. It has big pneumatic tires, foot straps, flexible decks and special tracks so it can easily handle rough terrain, and it's called mountain board. From that moment on, my life goal was to build such a board and ride it at high speed along the road during sunset. Yeah. So since then I have been saving money and getting as much information as I can about electric mountain boards. And I recommend Electric Skateboard Builders Forum because I learned everything from this site. And recently I have made some progress towards my goal because, as you can see, I bought this used mountain board for something around $100. So it's not expensive because the new one can be really pricey. But you know, it won't win beauty contest prize, but I think that for my first board it will be good. And I also have bought all the parts that are needed to make it electric, like motors and VSC. So that's why I'm starting this new series in which I'm going to explain you how to build your own electric mountain board, because there are a lot of tutorials already on YouTube about longboards and skateboards, but mountain boards are quite not popular, so I think it might be useful. And in this video I will talk quickly about all the parts that you need to build your own mountain board, and I will focus on the battery because that's the part that I need to test if all the other parts work. And in the future videos I will focus on motor, VSC, motor mounts, 3D printed pulleys, RC control, what else, programming VSC, maybe lights and printing covers for battery, for example, all of that stuff. So let's do this. Okay, so here we have all the parts. And the first and the most important thing is this speed controller for BLDC motor, and this one is Flipski VSC 6.6, and as you can see it has this nice aluminum case which is also waterproof and will help with cooling, so that's very nice, and it's made pretty good. It is good quality product, I hope so, and it can deliver up to 60 amps current according to Flipski, but to be safe I will use just 50 amps, and max voltage is 50 volts, so 12S, and it also features field orientated control, and that was something important for me because it makes the motor sound better and it also helps with efficiency. So that was something that was important for me, because before I also thought about buying VSC 4.12, but because it was cheaper, but it also would feature much smaller max current and it wouldn't work with this mode, so I decided to spend some more money to buy this bigger and better VSC. And the next thing is this BMS, which is very important for charging battery, and I will use this only for charge. For this charge I won't use it because money, it will be more expensive for discharge also, but I will explain more about this later. And also I have charger, so it's 42 volts, which is the voltage of fully charged battery, and it can charge at 2 amps, which is pretty slow, and it will charge my battery in 5 to 6 hours, but it was cheap, so for now I think it's okay. And also important part is this Flipski motor. It's a medium size because there are smaller models and there are also bigger models, but this one is medium and I think it will be good. It has max power of 3250 watts, so that's pretty nice, and it also can work with maximum current, which is 85 amps, but I will use it at 50 amps just to be safe, so it won't overheat, and it can work with up to 12S voltage, which I definitely will use in the future but for now I will just use it at 10s. And also important thing are these 8650 battery cells, and I bought 50 of them, and they were pretty cheap because I bought them from Polish seller that dismounts them from different devices and later sells them. But they are new, they are from the same brand, they are from the same year and from the same device. So that's nice. And their specs are not perfect for my board because they have pretty low capacity for such a cells, because it's 2100 milliampere hours, so that's pretty low. And it also has high current because it can deliver constant 30 amps. But you know, I would prefer something with, for example, 15 amps and higher capacity. But that's the one. But they were cheap. They were the cheapest one from that seller, so I went with them. And I'm going to make battery pack from them like this: 10 in series and 5 in parallel. God damn it.
Parallel.
Yeah, so I will make that battery pack with that capacity. And what else? Yeah, also important thing is nickel strip. I bought something about 6 meters of them with that dimensions, and that is optimal for 5 amps of current passing through it. So I think that I will use multiple layers in some places on my battery so it won't overheat. And if you buy nickel strips, you need to be careful because you need to make sure that this is pure nickel, not steel covered in nickel, because that would overheat. And what else? I also have these connectors because they are needed to connect to this VSC. And I have this big one that are rated for 90 amps, and I have also smaller one for charging battery. And that are the most important parts, and they are the most expensive. Together with board, everything here costs about $450, I think. So, you know, that's not bad because some builds are much more expensive, and I want my build to be pretty cheap because this is my first board and I'm just getting into this hobby. I also need to buy some more parts like motor mounts. I need to buy pulley for this motor, and I also need to buy some voltage sensors, some lights, some RC control circuits. So that also will cost me some money, but I hope that I will fit in the $520 budget, and that would be nice for this board. And now I can show you my very professional spot welder, and I will also show you how to connect these cells to make a battery from them. Okay, so here it is, my professional spot welder, and of course I'm joking, it looks like something from a junkyard, but it works. And the main part is this old microwave transformer, and I left this original primary coil and I cut out this secondary coil and replace it with this thick weldering wire. So there are just 2 coils, and the voltage here is high and the voltage here is low, but the amps are high. And at the end is this simple spot welding tip. I made it from a thin copper wires, and it gets very hot after a few welds, so that's not perfect, but for now it works. And here at the back is the whole circuit. It's very simple. There is just a relay, power cell, and this button, and when I press the button, relay gets activated, and this transformer gets power from the grid. And as you can see, if I press this, you would hear this transformer working. Yeah, it's definitely working. And I usually weld by just simply fastly pressing that button like that. And I could use Arduino for that as a timer, but I was just too lazy to do that, so there is no Arduino, but it can be easily added. And that's basically all. I'm going to show you how it welds. I have this 5-cell pack right here. They are glued together and they are connected at the top with this nickel strip, and you can see how it welds, the quality of these welds. It's not very good, but they are strong, as I said. And now I'm going to show you how it welds. So I will connect together this bottom side and so I have already first weld, and it's pretty strong. I usually do it like 4 times on one cell to make sure that it's strong. Okay, so now it's soldered. The cells are not hot, and that's a good thing. And this strip is also pretty strong. Okay, so here we are in Fusion 360. I'm going to show you how the battery will look like and how to make all the connections. So here we have one single cell, and by itself it's pretty weak. It has small voltage and small capacity. So first thing we need to do is to increase that capacity, and we can do that by gluing 4 more cells, and later we can weld to them this nickel strip at the top, so we connect all the positive sides. And also here where there is negative side at the bottom, we also need to connect them. So now these 5 cells in a row makes one S pack, so there is still 3.6 voltage, but it has much higher capacity, which is 10,500 milliampere hours. So that's pretty good, and that's going to be the capacity of the whole battery pack. So now what we need to do is to increase the voltage, because we can't run our board on 3.6 volts, and we can do that by adding, of course, more cells. So we can do that, and now this 5 cell pack is upside down, so that the positive terminal is close to the negative terminal, and this second pack also need to be connected like the first one, like that. And now we can connect everything with these short nickel strips. So the positive is connected to negative 5 times, and now this pack has higher voltage. It has the same capacity, but the voltage now is 7.2 volts or 2S. And now basically we need to make that 5 times, so there will be 50 cells in the whole battery pack. So we can of course add more cells, and here again positive side is on top and the negative is on bottom, and we also need to connect it like here. So you can see the pattern here, positive to negative, and here positive to negative also, and we will do that multiple times. So now we can add more cells, and we also need to connect them like that and like that. So now it's 5S battery pack, but we need 10S, so we can add the rest of the cells. And now there's 50 of them. That's basically the whole battery, and we need of course to connect everything. So yeah, that's how it looks. You can definitely see the pattern. And when we have that done, we can, for example, solder copper wires, so we can charge and discharge the whole pack, because there is negative side, there is positive side, and the voltage at the tips of this should be something around 42 volts when fully charged. And also I need to mention that these long strips, for example this one, they can be single, but in case of these short strips you need to weld them multiple times. So for example here I will need to weld 3 of them on top of each other, because they are capable of passing only 5 amps of current without overheating. So I need to increase them to 15 amps, so the whole battery won't be hot, and that won't be dangerous. So that's how the whole pack is going to look like. And now I'm going to weld everything, and later I will show you how it looks like, and I will explain you how to solder BMS and how to charge this thing.
12 seconds later.
Quick update, almost burned down my basement, and let me tell you how it happened so you can learn from my mistakes. So when I bought these cells, they came with these isolating stickers on top of positive terminals, and they are here because 8650 cells are designed in such a way that positive terminal is basically just this thing at the top, and negative terminal is at the bottom, but it's also all around the cell, and it's also at the edges of the cell, so basically the whole battery is negative terminal. So these stickers are here to prevent the short circuit, because if there weren't here, if you just, for example, weld nickel strip, you would breach positive and negative terminal and you will create a fire. So that's why they are needed. But after doing some research, I found out that these cells have already installed isolating gaskets inside, and this is this black ring, so we can safely weld these strips and nothing bad will happen. So I removed all these stickers because they were quite annoying while welding, because I have much smaller surface area here than here, and it was just harder to weld them. And I successfully welded like 25 of them. As you can see, this is this pack that I welded, and it's pretty nice. But later I made a mistake and I somehow breached one cell positive and negative terminal, and I still don't know how it happened, but that one cell caught on fire, and as you can see, this is the result. It was just burning in my hand. I was holding this whole battery pack with one burning cell for like 10 seconds, and I was just very surprised because I didn't connected anything wrong and that one cell was burning. But later I just quickly tore off these 5 cells in a row and throw it on the concrete floor and let it burn out. It was burning for like 2 minutes, but it didn't explode, so that's a good thing, and the rest of the battery survived because I quickly removed the burning one. But yeah, that was very scary experience, and remember, always use some kind of isolation pad on top of these cells, because that might save you from fire or just unpleasant experience.
Several days later.
Okay, I made it. I had to wait a while because I ordered a few new cells to replace the damaged ones, and overall it wasn't as easy as I thought at the beginning. It took me some time to connect every cell, but I made it. And as you can see, this is how it looks like. I've wrapped everything in this tape so I can hold this in one piece. And I have also already placed here this BMS, and I have soldered all the wires. So here are the balance wires and here are the power wires. And I was going to show you how to solder this thing, but it turned out to be very simple. You just do what this picture says if you have the same BMS as I do, and everything should be okay. And if you want to know more about battery management systems, I will leave some useful links in the description, and there will also be links to all the parts. And I have charged this battery pack for like 3 or 4 hours. So now we can check the voltage, and it should be something around 40 volts maybe. So we can just do that. And voltage is, this is the voltage of the battery, so it's not fully charged, so we can later charge it more. And as you can see, there are 2 power plugs, and this one is only for charging and this one is only for discharging, because this one is connected to the BMS and this one is just connected to the positive and negative terminal of the whole battery. So now we can just take this charger. I have soldered this plug to this charger, and we can just we can connect it here. So now you see that the LED here is red, so it means that it's charging. But I will charge it fully later. Okay, so what are my final thoughts about this battery? Well, I'm not very proud of it, and it's far from perfect, and I don't think this battery will last long because I made it after all, and I'm a bit afraid that some nickel strips might detach because of the vibration while driving, and that would be a very bad thing. But on the other hand, this is the first cell battery pack that I made, and I have learned a lot by building this thing, and I think that if I save some money in a few months, I will do another battery pack, this time correctly. It will probably be 12S battery pack, and I won't use hot glue to connect all the cells. I will just buy these cheap battery holders. They will be easy to use and there will be much less work with them. And my biggest problem in this battery pack were these nickel strips, because I bought one long nickel strip and I had to cut it to make these small pieces, and that was just a lot of work. And later I had to weld it multiple times to connect all these small strips, and that was very hard and very time consuming. So in the future I will definitely buy these pre-made nickel sheets. They will be just better, safer and stronger, I think. And of course I will also buy insulating caps for safety. And this video is already a bit too long, so I'm done talking. If you have any questions, you can ask me in the comments. If you have any ideas how I could improve this channel, let me know. I'd love to hear your opinion. So thanks for watching, and I will see you soon in the second part. And I even printed these pulleys for my wheel, so next video I will upload very soon. So again, thanks for watching and see ya.